Okay, hello from West Virginia. I think I might actually be there. Hopefully, I think so. Anyways, what I do know for certain is that I have joke of the day, and this one's great. Very timely with what we're going to be talking about today because, again, I teach in crazy ways. You're going to love this video. So, what did the wide receiver say to the football? Wide receiver on a football team, what did the wide receiver say to the football? Catch you later. Because that's what wide receivers do on football teams. They catch passes that are being thrown from the quarterback. So with that in mind, what we're going to be looking at today is graphing linear equations using our intercepts. We're going to be looking at the concept of what an X-intercept is and what a y-intercept is. And in my classes, I use a very unconventional way to teach X-intercepts and y-intercepts. And I like to talk about football whenever I teach math. So we're going to go to a clip that's going to demonstrate just where the idea of an X-intercept and a y-intercept comes from. So to learn about what an X-intercept and a y-intercept is, we're going to do a demonstration here. And I've got my son JD, who is going to play the receiver. JD, what is your job as the receiver?
Catch the ball and encourage it.
Yes, he's going to catch the ball because I'm all-time quarterback. It's my classroom, it's my house, all-time quarterback. So his job is to catch the ball. Isaac, JD's friend, what are you going to do? What position are you going to play? What position do you play? What?
Safety.
Safety, okay? Isaac, what is your job as the safety?
Not let him catch the ball.
Not let him catch the ball. But Isaac, what would be better than not letting him catch the ball?
Interception.
Yes, intercept the ball. That's what I want you to do, Isaac, okay? You're going to intercept the ball. So, let me get my gear on. Oh, yes, I am ready to go. I think I just broke my glasses. Okay, we're good. Okay, we've got this. Maybe. Okay. Now, Isaac, what I want you to do, Isaac, I want you to stand right here. Okay? This is our play. Isaac, you stand right there. Do not let him catch that ball. Okay? You ready? Sit. Hut.
You told me not to move. You said I had to stay right here. I'm not allowed to follow him.
Isaac, okay. All right. Let's try this again. So, Isaac, I tell you what. I want you to stand over here. Okay? Stand over there. Now, Isaac, don't let him catch this ball. Intercept the ball, okay? Got it? Ready? Sit. Hut.
Well, you told me to stand right here. I'm not allowed to move toward him.
Oh.
You're just letting me stay right here.
You need to intercept the ball.
I can't intercept the ball if I can't move.
Oh, okay. Fine, Isaac, fine. I'll tell you what. Move wherever you want. Run anywhere you want, okay?
Sounds good.
All right. We've got this. Isaac, intercept the ball, okay? Ready, set, hut. Oh my gosh! He did it! The crowd goes wild! Oh! Yes! Thank you, man. Better luck next time. And that, my friends, is an X-intercept. Okay, so you saw in the video that, and that was a lot of fun to film. You saw in this video that Isaac's job as the safety was to keep JD from catching the football. And you saw that when Isaac was pushed aside, he couldn't make it happen. The question is, when was Isaac able to intercept that football from JD? When did it happen? Yes, when Isaac got in front of JD. Now the point is actually this. When JD was standing, like for instance where I'm standing, and Isaac was over here, and I was throwing the ball this way, there was no way for Isaac to catch this ball because he was over here. And then when we moved Isaac over here, and once again JD's right here, and I'm passing the ball like this, there again was no way for Isaac to catch this ball because he was way over here and the ball was coming like this. The only time that it actually happened was when the ball was coming like this and JD's standing here and Isaac is right here. In other words, when Isaac was in between the ball and JD. When Isaac was able to cut across the path of this ball, he was able to intercept it. When he was over here and the ball's path is like this, Isaac was not able to intercept it because he was not in the way. He didn't cut across the path of the ball. When Isaac was standing over here and the path of the ball is coming like this, he's not able to intercept it because Isaac was not in the way in the path of the ball. But when Isaac was right here, cutting across the path of that ball, he was able to intercept it. Well, in math, an X-intercept and a y-intercept runs the same way. It's kind of like an X-interception and a y-interception. So the idea is this. Just like the only way that Isaac could intercept the ball was when he cut across the path of the ball, an X-intercept is going to be the point on that line where it crosses the, and mathematicians are not creative. So likely, where is this line going to cross? You guessed it, across the x-axis. Mathematicians are not creative people at all. We call it like we see it, and this helps so much. It helps me to remember an x-intercept is where it crosses the x-axis. So here's a picture representation of that. Here is my line, and here is my x-axis right here, and you can see where's that line crossing? Right there. That's my x-intercept. Now, I want to talk about this point that's on this x-axis. Whether that point sit over here, or whether that point sit over here, because if the line tilts in this direction, then the point's going to sit over here, or maybe the line goes vertically like this and it sits right here. But the bottom line is this. Being that the x-intercept is where it crosses the x-axis, that point is going to sit somewhere on this x-axis right here. It may sit over here and be a positive. It may sit over here and be a negative. It might be a fraction or a decimal. It might be an irrational number. It might even be the zero right here. But if it sits on this axis, there is something very special we know about every single one of these points. Notice that every one of these points have no up or down movement. Now, which of these two coordinates designates that up or down movement? Yes, that's the y-coordinate. So therefore, every one of these points on here, what can we say about all the y-coordinates for every one of these points? Yes, every one of them is going to be 0. So if we have an x-intercept, that means that the y-coordinate is going to be 0. Now the x-coordinate could be positive because it might sit over here. That x-coordinate could be negative because it might sit over here. It might be a fraction or decimal. I don't know what the x-coordinate is, so I'm going to make it a general x, but what I definitely know is that the y-coordinate is 0. So let's say that we have an equation. Let's say that we have an equation that might look kind of like this. Maybe a 3x plus 6y equal to a 12. And I want to be able to get the x-intercept for that particular equation because you know that graphs represent these equations. And I want to get the x-intercept. Well, let's think about it. What we just said is that an x-intercept, the y is 0. So what I'm going to do then is I'm going to take this equation, and where I see a y right here, I'm going to put a 0 in its place. So I'm going to set my y equal to 0, and notice what happens. When I do, what's anything at all times 0? Yeah, it's 0. So this entire term is completely gone. I'm just left with which variable? Absolutely, I'm left with an x. So can I solve for that x? Sure, all I got to do is divide both sides by 3. So therefore, I'm going to solve my equation for x because that's the only variable that's going to be left. So then I will know that my y is 0. I will then know what my x-coordinate is. In this case, it'll be 4. So I will have the point 4, 0 for that particular case. That will be my x-intercept, and I know that it'll sit over here. Now, how many points does it take to make a line? Yes, 2 points. We'll have one of them with the x-intercept, so let's try to get the y-intercept. Now, if an x-intercept is the point where the line crosses the x-axis, then what's a y-intercept? Exactly. Mathematicians are not creative, and it's so helpful. That's the point where the line crosses the y-axis. So here's a nice picture description of that. Notice that that line is recreated right here. Where does it cross this y-axis? Right there at that point. Now, it could cross up here. It could cross down here. It could be a fraction. It could be a decimal. It could cross right here at 0. The bottom line is this. Any of these points on this y-axis, I know something very special about every single one of them. What's special? None of them have a left or right movement. Now, which coordinate designates left or right movement? Yes, that's the x-coordinate. So every one of these points right here, since none of them have this left or right movement, what does that mean about the x-coordinate for every one of them? Yes, it's going to be a 0 because there is no left or right movement at all. Now, that y, it could be positive up here, it could be negative down here, it could be a fraction or a decimal, it could be anything. So I'm going to make a general y right here, but the bottom line is this. My point is the x coordinate is going to be 0. So once again, let's say we've got an equation that represents a line, and we're going to graph that line that represents this equation, and I now have my x-intercept. I need to get the y-intercept. What's it going to take? Well, we just figured out that any of those y-intercepts have an x-coordinate of 0. So I'm going to take this equation, and wherever I see that x, I'm going to turn it into a 0. So I'm going to set my x equal to 0, and notice what happens. Again, what's anything times 0? 0. So what happens to this term right here? Totally gone. Which variable you left with? Yes, I'm left with a y. Can I solve it for y? Absolutely. I'm going to divide both sides by 6. So what I'm going to do then is I'm going to divide by 6, and I'm going to get y equal to 2. And that will give me my y-intercept. The x was 0, the y came out to be 2, and that's going to sit up here. There's the 2 points that it takes to make the line, the 4, 0 here, the 0, 2 here. I'm going to connect them. Voila, I got my line. So to find that y-intercept, set the x equal to 0, solve it for y, but again, put it in coordinate form. Now you may be asking, why is it so important that we put this in coordinate form? What's the big deal about that? Because some textbooks don't force you to put it in coordinate form. Some textbooks here will let you list that your x-intercept is simply a 4 and that your y-intercept is simply a 2. Now my students, I insist that they put it in coordinate form. Here's why. That 0.40 is going to sit over here, but what if I put my 0 in the wrong place? What if I say my x-intercept is 4 and I put the coordinate like this? Well, 0, 4 is going to sit up here. That's a totally wrong point. Similarly, my y-intercept being 2, well, that 0, 2 sits up here. But what if I flip it around and I get my 0 in the wrong place and I call it 2, 0? That's over here. See, it's very important that you understand where the 0 goes in these coordinate forms. So like I said, it depends on your teacher and your textbook as to what will be accepted. My students, they always have to write it in coordinate form. Crazy important that my students know where that 0 goes. So I will always insist that my students put it in coordinate form. So let's try a few more examples to make sure we feel really comfortable with determining these x and y intercepts and being able to graph our lines based on the x and y intercepts. So take a look at this equation here. The directions say we're going to graph each of these using the x and y intercepts. This equation, I'm going to find the x-intercept, and I'm going to find the y-intercept. Now, what's it take to find the x-intercept? Now, you might be one who can memorize stuff. I'm not that great at memorizing things. To be completely honest with you, I don't, and I really do always get it confused as to which one I set equal to 0. I sincerely get it very confused. So what I always have to do, because I can't memorize this right here and I can't memorize this right here, I always go like this. Okay, x-intercept, by definition right here, and let me highlight this. By definition, the x-intercept is where it crosses the x-axis. Any point on this axis has no up or down movement. That's the y-coordinate. So to get an x-intercept, I need to make my y 0. So what I'm going to do then is I'm simply going to make my y 0. And like we said before, that means I'm going to put a 0 right here where this y is. When I do, I will have 5x plus 4 times 0 equals 20. And like we said before, anything times 0 is 0. That term is completely gone. I'm left with 5x equals 20. And what do I do now to get x? Yes, I divide by 5. And when I take a 20 and divide it by 5, I get a 4. Now remember, my students, critically important that you put that in coordinate form. The coordinates for this are the x is 4, the y is 0, because I made the y 0. But that gives me the first point on the graph, and it's going to sit right here. There's my x-intercept. And you can see, yep, it does cross the x-axis. Now let's get the y-intercept. What's it take to get a y-intercept? And once again, remember, I'm not one who's that great at memorizing anymore. I used to be amazing, but not so much anymore. I don't have this memorized. I don't have this memorized. What I do have memorized is the definition right here, right there, that a y-intercept is the point on the graph where it crosses the y-axis. So since I can't memorize all this, I just go, okay, Y-intercept crosses the y-axis right here. Any point on this axis has no left or right movement. Left or right movement is the x-coordinate, so I'm going to make my x 0. So in order to find my y-intercept, what I'm going to do then is I'm going to make my x 0. And so like I said before, that means I'm going to put a 0 right here where the x is, turning that into 0. And then remember, anything times 0 is 0. The entire term is gone. I'm left with 4y equals 20. And we know to divide by 4 at this point, that's going to give me y equals 5. And again, my students put that thing in coordinate form. The x was 0, the y came out as a 5, giving me the point 0,5, which sits right here. Yep, it does cross that y-axis. How many points does it take to make a line? 2. I got them. So I'm going to connect this, and with me, you got to pray it's straight because I cannot draw a straight line. Hey, not too shabby for me. And there is the graph that represents that equation. Okay, let's practice a little bit more with this. Whoa, fractions. That's a little bit scary. Don't sweat it. Don't freak out. They tend to work themselves out. So remember, with the x-intercept, what do we got to do? Make the y 0. So I'm going to make the y 0 in this one. Put a 0 right here where the y is. And what happens is now I've got a negative 1/3 times 0 equal to 8. But remember, 0 times anything is 0. This entire term is gone. I'm left with a negative 1/2 x equals 8. And then remember, what I'm going to do is divide by a negative 1/2. But we've talked about this before. If I try to go through and do this, dividing by a negative 1/2, wow, that's a nasty mess right there. That's a complex fraction. I don't want to deal with a complex fraction. But we talked before about dividing by a fraction is the same thing as doing what? Yes, same thing as multiplying by its reciprocal. I'm going to go for the jugular, and I'm going to multiply by the reciprocal of negative 2. Because remember, when you multiply fractions, there it is again. Yeah, our little math gang here, we're going to cancel on those diagonals, and we're going to shoot straight across. So we're going to cancel on these diagonals. We're going to multiply over here. And so that's going to give me my x equal to a negative 16. And I'm going to put it in coordinate form, very important. So my x is going to be a negative 16 when my y is a 0, giving me the point negative 16, 0. Now I'm going to count by 2's because there's not enough space here. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16. There we go. There's my negative 16, 0. Yes, that's crossing the x-axis. Now let's take a look at this y-intercept. What's it take to get a y-intercept? Yes, make the x 0. So we're going to put a 0 right here where this x is, giving me a negative 1/2 times 0 minus 1/3 y equal to 8. And like we said before, now this term is completely gone because 0 times anything is 0. Totally gone, left with a negative 1/3 y equal to 8. And like we said before, yeah, I'm going to go through and I'm going to divide by that negative 1/3, but wow, what a complicated, complex fraction. So I'd rather go for the jugular. I'd rather just go ahead and multiply by its reciprocal, which is negative 3. I'm going to cancel on the diagonals, totally gone, left with that y. And I'm going to do the same thing on the other side and multiply by a negative 3 over here, and that will give me a negative 24. So my y comes out as a negative 24, and once again, my students put that thing in coordinate form. So that means that I made the x 0. When I did, the y came out to be a negative 24. There's my y-intercept. And again, I'm going to count by 2's because I don't have enough space here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, right there. And now I'm going to connect them. Oh my stars, what a mess we have here. I'm going to pray that this thing is straight. You never know with me. Not too shabby. I think I got it that time. So this is the line that represents that graph. All right, one last one. So once again, and you might notice, wow, this looks a lot like this. The only difference is this had something like it was an 8, and this has just a 0. What's going to happen? Let's see. So to get that x-intercept, we said make that y 0. And just like we saw before, when we make that y 0, remember, that means this entire term is gone. And we're left with a negative 1/2 x equal to 0. And we said, okay, the next step was going to be to divide by that negative 1/2. And we figured out, no, go for the jugular. Cleaner, faster, easier. Multiply by its reciprocal. And when I do, it's going to cancel out those fractions. I'm left with x equals 0. So when I put it in coordinate form, I'm going to get x is 0, y is 0. So therefore, here is my x-intercept. Now, if I'm not thinking clearly, which unfortunately happens with me a lot, I go to get that y-intercept and I know, okay, that means make the x 0. Well, when I make the x 0 right here, that means I'm going to put a 0 in its place, and I'm going to wind up with this. And once again, that term is gone, because anything times 0 is itself. I'm going to get this, and once again, I'm going to divide by that negative 1/3, and I'm going to go, no! I'm going to go for the jugular. I'm going to multiply by the reciprocal. Cleaner, faster, easier. So that will give me a y equal to 0, and once again, oh my goodness, x 0, y 0, it's the exact same point, which we should have been able to see. Once we saw that the x-intercept was 0, 0, remembering that the y-intercept is where it crosses the y-axis, it's crossing the y-axis in the exact same point. It's okay to have the x-intercept and the y-intercept as the same point. Don't freak out when that happens. It happens and it's okay. But the problem is now, how many points does it take to make a line? Yeah, it takes 2. It takes 2 to make a line. Okay, that just kind of came to me. But anyways, what I definitely want to do now is I want to figure out, where's that second point? What am I going to do now? Well, you're still buzzing from the, it takes 2 to make a line. I couldn't help it. Anyways, so what I'm going to do now is I'm going to go, oh yeah, we have the point plotting method. And remember, the point plotting method said pick anything you want to plug in for the x or the y, it doesn't matter. And then follow the order of operations and see what spits out. So that's what I'm going to do. Now remember, whatever I plug in here for the x or whatever I plug in here for the y, I'm going to be multiplying to those fractions. I'm going to make my life easy. I want to either pick something here that's going to cancel with the 2 or pick something here that cancels with the 3. And it doesn't matter where you go, just pick something that's going to cancel so that your life will be easy. So if that's the case, then I think that what I'd like to do is pick something to put in here for the x that's going to cancel with that x. So I think I will pick an x 4. So that means I'm going to put a 4 right here where that x is. When I do, I get a negative 1/2 times 4 minus 1/3 y equal to 0. And at this point, negative 1/2 times 4, remember, I'm going to cancel those diagonals. 2 goes into 2 once, 2 goes into 4 twice. I'm left with a negative 2. So I have a negative 2 minus 1/3 y equal to 0. And what I'm going to do is slide that 2 to the other side, add it to the other side, giving me a negative 1/3 y equal to 2. And now what am I going to do to get rid of that fraction? Yes, the same stuff I did over here. Multiply by the reciprocal, multiply by the reciprocal. I'm going to do the exact same thing. I'm going to multiply by a negative 3 here to cancel, multiply by a negative 3 here, and a 2 times negative 3 is going to be a negative 6. So that gives me a second point on the graph, and that point is going to be 4, negative 6. So, unfortunately, I've really done a terrible job not giving myself enough room. Maybe I should have picked a negative 4. But anyways, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So negative 4, 6 is going to sit right down here. And we're going to connect them. And there is the line. And that is the line that represents that equation. So, I hope this helps you to understand how x-intercepts and y-intercepts can be found if you're given an equation, because once you find them, you can put them on the graph, and it only takes 2 points to make a line. You'll have the 2 points because you'll have your x-intercept, you'll have a y-intercept. And remember, in terms of finding the x-intercept and the y-intercept, you don't have to memorize really anything at all. You just need to know the definition of what they are. An x-intercept is the point where the line crosses the x-axis. Mathematicians are not creative. We call it like we see it. X-intercept, x-axis. Y-intercept is the point where the graph crosses the y-axis. Again, mathematicians are not creative. We call it like we see it. Y-intercept, y-axis. I hope that helps. Have a great day.
You go like that.
Oh.
Ow. Oh.
That's so tight.
Yeah, no, around the ears.
Yeah. Thank you, guys.